Okay, so this is the last section that we're doing in chapter 12, and it's about the normal distribution. And so this is often called the bell curve. A normal distribution is distributions that make this symmetric curve, which means the mean, median, and mode are all about the same. That's kind of what a normal distribution is. So maybe you could write that. The mean, median, and mode are all about equal, so they're about equal. About the same. We're going to talk about how this works in a minute, but like this would be your mean right in the middle. And so half your data is less than the mean and half your data is greater than the mean. It's why some teachers joke about if you ask if you're going to curve the test, if you curve the test, that means the majority of people would be in the middle, which means they would get C's. Very few people would be at the A and the B mark, and very few people would be at the C and the D mark. Sorry, the D and the F mark, right? This would be all the C's. What we hope that happens in math is that we have some skewed distributions. I guess maybe I did that the wrong way. But this is positively skewed, and I always have to look this up because I always think it's the other way around. But positively skewed is when your data is here, like bunched together here, which means your mode is less than the mean, right? That's a positively skewed data, where this is an example of a negatively skewed data. And so part of what we're going to ask you to do is the difference between normal, positive, and negatively skewed. So let's look at some data, and I'll show you how you can figure this out. So it says determine if the data is positive, negative, or normally distributed. And there's just a bunch of numbers here. And so what I did when I did this is I kind of made like a frequency table of how many times did these numbers appear, because it only goes from, what, 31 to 37? So what I did when I did this is I actually like wrote out the numbers like 31, 32, 33, 34, 35, 36, and 37, and kind of made a frequency table of how many times they appeared. So 31, there's only one 31, so I can kind of make a little bar graph here for 1. 32, 1, 2 32s. You could also do like tally marks, I guess. 33, there are no 33s. 34, 1, 2, 3, 4 34s. So I'm going to go like this. I guess I don't like this numbering here that I did. Here, I'm going to change this. It should be more like, this would be like 31, 32, 33, 34, 35, 36, 37, right? 35, 1, 2, 3. So that would be like here. 36, 1, 2, 3. That would be like right here. And 37, there's only one 37, which my number, like my bars are getting bigger, but kind of looking at the frequency here, what do you think? If you still aren't sure, you could go with the mean, median, and mode. If I computed the mean here, where I added them all up and divided by the number of numbers, and the mean was 34.35. Think about the mode on this one. It's really easy to tell the mode if you make a bar graph like this, because this is the biggest one, right? 34 is the mode. And think about if you did the median on this. The median, there's one of these and one of these. There's two of these, two of these. And then if you went in 1, 2, 3, 4, 1, 2, 3, 4, you would be right here in the middle of 34 and 35. So without actually having to write it all out, I can tell that the median is 34.5. So looking at those, the mean, median, mode is pretty centered, right? And if you look at that, that is kind of like a bell curve. So we would say that this is normally distributed, okay? But here's the big thing I really want to talk about is normal distribution. Normal distribution, what do I have here? Oh, I just said that already. The mean, median, mode are about equal, but what's really cool is if your graph is normally distributed, then we can talk about standard deviations and how many standard deviations away from the mean. So if you have a normally distributed graph, you have your mean in the middle, okay, which I'm going to write my mean as an X with a bar above it. And you could break this up where each one of these little bars is going to represent like a standard deviation away. So if you remember, the symbol for standard deviation is we use this little omega. And if you break this up, then 34% of your data should be on one standard deviation away, which means we could really say, if you add that up, 68% of your data will be one standard deviation away from the mean. And I'm using the symbol for mean, which is x with a bar above it. So we can talk about that standard deviation. And then this one, if you break up and go 2 standard deviations away, 13.5% of the data should be in each one of those. So 13.5%, if you add all that up, that's 95% of your data. So if your graph is normally distributed, then 95% of your data should be within 2 standard deviations of the mean. And then the last one, we actually break it up even more. At 3 standard deviations, that's going to be 2.35%. So if you add that up, that means 99.7% of your data should be within 3 standard deviations of the mean, which leaves 0.15% left that would be outside of that. So if it tells you it's normally distributed, then you know these percentages, okay? So let me show you what that means. So it says Mrs. Bash gave a quiz, Mr. Bash gave a quiz in his social studies class. The scores were normally distributed with a mean of 21 and a standard deviation of 2. So what this means is if they tell you that it's normally distributed, you can make a little bell curve here, and you can say, okay, the mean was 21, so that's here. The standard deviation is 2. So if I go 2 away on each side, that would be 23 this way and 19 this way. And if I keep going by the standard deviation, this would go 25, this would go 27, this would go 17, this would go 15, right? So you use the mean and the standard deviation, and then they can ask you, what percent would you expect to score between 19 and 23? Well, 19 and 23 is 1 standard deviation away, so that would be 34 and 34, or that would be 68% of the class. What percent would you expect to score between 23 and 25? Well, the next number I gave you up there was 13.5%. So between 23 and 25, that's 2 standard deviations away, only on this side, so 13.5%. And what is the probability that a student scored between 17 and 25? Well, 17 to 25, 17 would be also 13.5%. So that would be within 2 standard deviations. Probability is a percent, right? So 95% chance that they scored between 17 and 25. So when it says normally distributed, you can do this. All right, so what I want you to do is see if you can write this one out, and then we'll talk about this one in class before you do it on your own.